added. Or I take HOH, okay, that is what I am going to show. So HOH will break H plus OH minus. This is electrophile. This is nucleophile. Okay, then so both will be added. Whenever there is a carbon-carbon double bond, or carbon-oxygen double bond, or carbon-nitrogen double bond, pi bond. Pi bond is a symbol of unsaturation. Nothing was there, so they made themselves to compensate, to satisfy the 4 valency of carbon, to satisfy the 2 valency of oxygen, to satisfy the 3 valencies of nitrogen. It is a symbol of unsaturation, understand? Now, whenever this pi bond is there, there will be addition possible. Here, this addition we already discussed, electrophilic addition. But addition means what happens, this bond will break, here one will be added, here one will be added. That means the electrophile may be added here, nucleophile may be added here. Or nucleophile this side, electrophile that side. That all we have studied Markovnikov's addition, anti-Markovnikov's addition. All we discussed. It was studied by the scientist and conclusion was made in his name as Markovnikov's rule, anti-Markovnikov's rule or Karash rule. That is not my discussion. That is not my aim to make you to understand. Here, what is the thing is, why it is called the electrophilic addition in carbon-carbon double bond. And why here we are calling it as a nucleophilic addition, even though electrophile is added and nucleophile is added. You see that this name is given based on who will attack first, as per the mechanism proposed. Okay, because mechanisms are proposed from stability of intermediate, hyperconjugation, inductive effect, everything will be taken into account. So they propose a mechanism. As per the mechanism in that, I have taught you the mechanism of Markovnikov's addition and anti-Markovnikov's addition. There you easily understand it is especially Markovnikov's addition. Anti-Markovnikov's though free radical mechanism. So Markovnikov's addition, it is an electrophilic addition because electrophile will attack first. Here nucleophilic addition, we understand that here nucleophile will attack first. Okay, so here I take a carbon-oxygen double bond alone. The remaining I am putting dash. Okay, and I told you already. I have told you this is having delta plus and this is having delta minus. Okay, so now what I am using the symbol nucleophile and U minus 2 lone electron. This is the minus indication. So definitely this will attack here. When it is attacking here, it will go this side. Here already 2 lone pairs are there. This is how you have to write that general symbol. Right now I am writing carbon. These 2 bonds coming here because one more is coming. This nucleophile is attached, and here oxygen is now having 3 lone pair with 1 bond also. That means 1 electron extra. So this minus sign will come here. This minus sign will come here. Then what happens? That electrophile, that is generally proton from the solvent medium. Now this C nucleophile. You see that the shortcut is C double bond O 2 bond. Directly shortcut is what? That C 2 bonds will be there. One side that nucleophile you have to identify, other side that oxygen will be attached with OH. This is the shortcut manner you remember. Otherwise, this is the mechanism I have taught. Right? Okay. Now all of you add water. All of you add water. Add water is the reagent. Water is the reagent. Acidified water. Now write down this. What is this? We write C double bond OH plus HOH. Okay. Now what is that? C2. That in this HOH, this is a nucleophile. This is an electrophile. So nucleophile will be here OH. Here OH. And you see that what happened? This is highly unstable, I told you. If it is highly unstable, what happens? C double bond and this water will be removed, and that means it will become that. That is it. Now next you write down HCN, you add HCN. So here when you add water, you are getting diol. That also alkyl lidine diol you are getting. Since it is unstable, it will break to give a corresponding aldehyde or ketone. Okay. Now see HCN you add. What will happen in HCN? HCN carbon, 2 bonds are already there. Sorry, 2 bonds are already there. And here one nucleophile, what is the nucleophile? This is nucleophile, this is electrophile. So CN will be added. This with oxygen, this KH plus will be added. And this is called the cyanohydrate. Now you look at the textbook, you will understand better. Cyanohydrate. Cyanohydrate. Now add the alcohol. Practice, you take the rough paper, you practice. I'm just showing the problem. C double bond O, two groups are attached. These two groups may be RR or RH. That's why, because aldehyde, ketone, both are there. Right? Now you write ROH. In ROH, what is this? This is H plus minus. So here, what is the product you will get? C, two bonds are there. Nucleophile is OR, and this is O will be attached to it. This is a double bond O, this H will come. Okay, so this is hemi-acetal. Okay, here one more ROH you add, because already this OH group is there. So one more alcohol is added with this C, two bonds OR is there. This also will become OR. So this is acetal. Okay, it is almost equal to name reaction. Note down this reaction. Many times it is asked in the board exam, hemi-acetal. Only one, there is carbon, there is a ether type. OR is added, alcohol from alcohol, OR is added only one time added mean, that is hemi-acetal. In two times it is added in the carbon mean, which is called as acetal. Next you write down the reaction yourself. Sodium hydrogen sulfate. Sodium hydrogen sulfate. You write, because here I want to tell you, if you slightly overview, see that I'm going with, you will be missing one question. Now you take this aldehydes or ketone. I will go first question. C, R, and double bond. Aldehydes or ketone. Now here you write that NaHSO3, sodium hydrogen sulfate. Tell me now, this is Na plus, this is the minus. Write down. What is the product you will get? R, carbon, R, this is right. This is O is there. Here only addition will take place. Here one carbon nucleophile will come. This is SO3H I am writing, because sulfur only will have that. And here Na, okay, minus plus. Okay, so this will be crystallizing. This addition product will be crystallizing. So once it is crystallizing, what will happen? Once it is crystallizing, here the 2 points you note down. See that here this due to steric factor, if it is ketone, due to steric factor, the product formation is less. Means we say in terms of equilibrium, the reaction is towards the backward direction, more favorable towards the backward direction. Because due to steric factors, see why steric factors are we are talking about. See that here, how many are there? One. It is a tetrahedral sp3 carbon. But see all bulky groups, So due to steric factor, this product formation will be very less favorable. Okay, it will form, but not much. So if it is aldehyde, what happened? It is favorable. So instead of this one hydrogen you take, now here it will become hydrogen. Now it is more favorable. Okay, this is one point you note down. Right? The second point is, since it is crystallizing, what happened? More and more product will form. Okay, that is not clear. And here you write down the point number 2. First point I already told you about ketone and aldehyde. Ketone less product and aldehyde more product due to steric factor in ketone. The second point you note down is this method is used to, this important information, this method is used to separate and purify aldehyde from any mixture. Because during the preparation of any compound, some byproducts and all will be there. The main worrying thing is not only for us, chemists, scientists, everybody, the difficult part is separation and purification. So here, this is very much useful for the separation and purification of aldehydes. Okay. What is the reason? Because you write out the reason. This is the statement given. Reason is this compound, the crystallized compound, that can be easily converted back into, because once it is crystallizing, by filtration you can take it out. Okay. Then after that, what happened? You can easily convert back. Easily means what? By very simple method, by hydrolysis or by treatment with some basic solution. Either that is called simple method. By simple method, you can convert back into aldehyde. Okay, so whenever some aldehyde is prepared, you want to separate them, means what you do, you take sodium bisulfite, and then this addition reaction will take place, the crystal will form. Take the crystal, then convert it back to aldehyde. See, you have taken out aldehyde from the mixture, then you got it back in a pure form. Okay, so that is the thing. So that point also just you write down. Because by treating with the mineral acids and alkali, you can easily get that. Okay, so that is, you write down something. So this is by alkali or acids or base. You can easily get it back. Okay, so this is crystallizing. So once it is crystallizing, more and more product will form according to each other principle. But then, sir, that you are telling for ketone more product will not form. Yes, that is ketone. This product formation will be less amount itself, that equilibrium will be attacked. Right, because of stirring factor, but only so it will show some resistance towards this reaction. But as far as the aldehydes are concerned, they will react easily. Right? So I hope that, and even variety of such reactions are given. Ethylene glycol. Ethylene glycol, I don't want to write all the reactions. I already given cyanohydrate and sodium bisulfite reaction addition, even HOH addition I showed you, and now acetol and hemiacetal I have shown. Only one is in the hemiacetal acetal only, but in the instead of ROH you can use the glycol, CH2OH, CH2OH, so that it will be getting attached in the same pattern. Okay, so now next one is addition of ammonia also. You can take that NH bond will add, NH means N will be plus, H will be plus, N will be minus. In the same bond you add and practice. Okay, now next is about the reduction. The next second important reaction is reduction. Here also two name reactions are there. First, let us see what is normal reduction. And the normal reduction, aldehydes or CHO or RCO or anything, if you are reducing by sodium borohydride, these are the reducing agent. Lithium, aluminum hydride. These are normal strong reducing agent. Okay. So here reducing agent, what happened? The next reduction is only RCO2. Okay. Here RCHOHR. What on that? This is secondary alcohol you will get. Here primary alcohol. This is not the first time. This is in alcohol chapter preparation. You can see. I am not supposed to teach this. I already wasted 50% of the time for what you have studied in the previous chapters. Of course, 11th I have to remind you, but even previous two chapters, what you studied, no need to cover up. Many reactions I taught you is from that one. Similarly, in the next part, again, many will be repeated. So you will read and come and attend the class. Okay. So here, this point we write down, aldehyde will give primary alcohol and ketone will give secondary alcohol. This is one reaction. Another one is name reaction, just to see that there is a Clemmensen reduction. That in both the cases, I will just to show only the reaction pattern. In both the cases, this is the one, and in another one also the same thing. That this C will be there, and here the C H, this double bond will be completely removed. Okay, here one valency hydrogen, another valency hydrogen. So this will become CH2. Right? All of you understood that here? Okay, now you just note down that point first. I will just remove this place and so now see that suppose you are taking C, or I will take it better to go with R. R, C, O, H, aldehyde. So now what happened? You will get R, CH3, because this will become H2, 2 valency, 2 hydrogen. That is the pattern of reduction in both the cases. Okay, so now what it is? One is Clemmensen reduction, first one, Clemmensen reduction, and another one is Wolff-Kishner reduction. Okay, Clemmensen reduction, what is that? Both same pattern, but is that reducing agent is the different. Okay, so in case zinc mercury amalgam, we can represent like this and the HC. Okay, and here it is hydrazine, NH2, this is hydrazine, and ethylene glycol and all will be there in the second step. This is first step, and the second step is, what is that? Solvent is glycol, ethylene glycol, and KOH and heat. The Woods reaction, Wittig's reaction and all. Okay, right. Now then last oxidation. This oxidation, again I already told you in that one, that you see that in case of oxidation, in case of RCHO, you will get RCOOH. You can use any given K-monoprotol, you can use, because no need to control. Controlling, when you have to control, you see RCH2OH, it will become RCHO, then lastly it is RCOOH. This is the oxidation. But here, when you have to control, when you prepare, now we are not studying preparation, properties. Okay, when you prepare aldehyde, you have to stop the oxidation up to this. That is why you cannot use K1O4, because K1O4 will start from here directly, it will not stop, that will go directly. You will not have a halt here. So we are using PCC, we are using different CrO3, like the different chemicals we study. Even this chapter again extra we study. But now here no control, because this is, you are starting from the second stage. Here to here it is no more, next is burning only, combustion. Okay, so here anything you can use, K1O4 you can use, and dichromate you can use, not a matter. Okay, oxidation. But only thing is what happens, same number of carbon. That point you note down, same carbon, same number of carbon. Right? Now, but in case of RC double bond OR, here what happened, one CC bond should break. I have taught you before also. Here what happened, you will get R, this R portion, and another one is this is this portion. That is RC, that C will become COH. But here this R itself, if suppose that R is CH3. So what you will get, HCOOH, one carbon acid. If suppose this is CH3, CH2, ethyl group, and then you will get the acid CH3COOH, 2 carbon acid. Like that you remember. But one CC bond will be broken. Once the CC bond broken, some carbon is missing. So here you will get less number of carbon. You will get a less number of carbon. That point you note down, less number of carbon. Actually, I forgot to tell you one very important reasoning question. Of course, I will be discussing later on again, but now we just note down. Come back to the first chemical property. All of you note down. Compared to the first, I am not going to write and explain. I will explain and you will try to make the point. Compared to the first chemical property, nucleophilic addition. Nucleophilic addition on carbonyl group C double bond O. You tell me, ketone is more reactive or aldehyde is more reactive? Consider the point, the first step, the nucleophile will attack the carbon. Nucleophile will attack the carbon. Nucleophile will attack the carbon. Carbon of the carbon oxygen double bond. And that is that both ketone and aldehyde, nucleophile will attack. Considering this point, you tell me which is more reactive. More reactive means easily it will react. Easily it will form the product. Any one of you tell me, aldehyde is more reactive or ketone is more reactive? Tell me. Somebody is switching on the mic. Tell me loudly.
Aldehyde.
Aldehyde, why? Good. Answer is correct, but why?
Sir, in ketone 2 R group is there, so more steric hindrance.
Okay, write on that. Very good. So more steric hindrance in ketone for the nucleophilic attack. That you have to use that, not simply without complete statement. Don't say. By the attack by the nucleophile or in nucleophilic attack, ketone has more steric factor. So nucleophilic attack on the carbonyl carbon is difficult when compared to aldehyde. Okay, therefore, in nucleophilic addition, aldehydes are more reactive. Okay. Now, lastly, let me write almost time, but I just not time that I thought of having up to 1 o'clock, but I'll wind up within 5 minutes. Lastly, we will discuss about one what is that a distinguish between. Okay, so this is the distinguish. I told you one always distinguish between question will come. But before it is comes under this category, but before that, let us discuss what it is. That is a test for aldehydes. So that you can distinguish between aldehyde and ketone. Okay, aldehyde and ketone you can distinguish by this reaction. The first one is tolerance reagent. Okay, it's better one or two things you have to understand. In the textbook reagents equation is there, you can write the equation. See, if the question paper is very tough, they will not, without the equation also, they will give the mark for you. If the question paper is very, very simple, then if they may reduce that half mark for not writing the equation. So better you study the equation also. Very simple, that is only otherwise simply you write, no problem. That what you write is tolerance reagent, first of all you write ammoniacal silver nitrate. Ammoniacal silver means ammonia. What is that acidified means? Similarly, ammoniacal. Ammoniacal means ammonium hydroxide. Few amounts will be added. Okay, so ammoniacal silver nitrate. Okay, actually it is Ag plus. One complex will form with ammonia. That is why it is ammoniacal silver nitrate. So it will be more stable with complex. Ag plus is actually. Now this is RCHO aldehyde. It will become H. And that RCH, because this, what is this? This is oxidation or reduction? Reduction. That means definitely what should happen? Here oxidation should happen. What is this? RCOOH. Okay. So now what is this silver? You know, silver is a metal, a grayish metal. So this is actually, this test is called silver mirror test. Even actually now you didn't have the practicals, and otherwise I thought of carrying out this test. Even it is that in your practical also. Silver mirror test. You will be heating it actually in a water bath. Okay, hot water will be there, and the boiling tube or test tube will be kept inside this. What is that? Inside that it is this ammoniacal silver tolerance reagent is there. An aldehyde will be given. It's a test for aldehyde. So in the heat, after that, after some time you take this. To take this, I'll choose some other green color. See, inside this, that this silver deposit will be there. So this silver deposit means that the mirror for seeing our face and all, the mirror we use now. What is that actually? That is the silver deposits are there, and some silver compounds are there. So since the silver deposit is there, it will be looking like a mirror with a silver grey color deposit, metallic silver deposit inside. So we call it as a silver mirror test. Okay, so this is what this test will not be shown by a ketone. Can anyone tell me why? Sir, the aldehyde is undergoing oxidation. Actually, this tolerance reagent is an oxidizing agent. Tolerance reagent, see, many points you have to understand. When I told you silver mirror test, as Ag plus is reduced, therefore aldehyde will be oxidized. Okay, but actually that if you understand the complete reaction, tolerance reagent you are putting inside our substrate main is aldehyde. That means tolerance reagent is acting as an oxidizing agent. So then ketone also you put, it will become acid, and again that silver plus will be reduced into silver. But I told it will not be shown by ketone. because this test is used. That is the reason this test is used to distinguish aldehyde and ketone. I am giving two test tubes. You do not know which test tube contain aldehyde, which test tube contain ketone. Two test tubes I am giving. One contains aldehyde, one contains ketone. That's all I am telling. Both are looking like water, colorless. Okay. Now what you will do? Carry out this lab tolerance agent is there. Add it and keep it inside water bath for some time. Go and take it. If the silver color formed, it is aldehyde. Not formed, it is ketone. That means question comes. Why ketone is not reacting? Write down the point. Ketone is because tolerance reagent is a very mild oxidizing agent. It cannot oxidize ketone into carboxylic acid. Then again question you will ask me, sir, why? Because in oxidation of ketone into carboxylic acid, just now I told you there is a need of breaking of carbon-carbon bond, which is very difficult. Carbon-carbon bond, but difficult means for the tolerance reagent it is not capable. So write down the reason why ketone cannot be oxidized by tolerance reagent. Tolerance reagent by nature it is a mild oxidizing agent, point number one. And ketone converted into carboxylic acid needs a breaking of CC bond, which has a high bond enthalpy relatively. In aldehyde only CH bond is broken. These are the reasons you have to. Okay. And similarly, another one test, second test. With this I am winding up. The second one is Felling's test. Felling's test or Felling's reaction we say. The Felling's reagent will be used. Okay, Felling's reagent means that it is a mixture of Felling A. Felling A plus Felling B. Felling B. This is only Felling. This is called Felling's reagent. Is also again a mild reagent that only aldehyde will answer. This Felling reagent will have Cu2 plus, cupric. Cupric, you know that it is a blue in color, the solution will be blue, copper sulfate blue color. But during this reaction with aldehyde or CHO, this will be reduced into Cu plus, cuprous. This cuprous is reddish brown color. So reddish brown precipitate will form. And this will be oxidized into RCOO, carboxylic acid. Okay, write down that this is reduction. This is also mild reducing agent. So here you just write down Felling's A is alkaline aqueous. Alkaline means some alkali is added, base is added. Aqueous copper sulfate. Alkaline aqueous copper, means copper sulfate, you know, the blue color salt dissolved in water, add few drops of NaOH, alkaline. Okay, NaOH should take dilute NaOH, few drops. Alkaline aqueous copper sulfate solution. And Felling B, that is aqueous copper sulfate you take, sorry, correction. Alkaline is for the B only. So here potassium, sodium, potassium tartrate. Okay, so I will give in a separate page. Tartaric acid, tartrate means what? Salt of tartaric acid. Tartaric acid is CHOH. COOH, CHOH, COOH. Means one carbon, COOH, here H, OH, and again one COOH. And only I am writing OH, H. CHOH, COOH, CHOH. This is tartaric acid. So now what happened? This is when you use acid means it is a strong metal when you use. They will form what? This is minus. So here K plus. If you use both potassium hydroxide and sodium hydroxide, both are possible to get attached. This is only, but here again, what is that? Since you have, this is prepared by adding alkalina, because tartaric acid plus NaOH and KOH. So that reactor will be there automatically. So that's why we say alkaline. This is only Felling's B solution. Felling's B solution, write down alkaline. Felling A, please correct it here. Felling A is only copper sulfate dissolved in water, aqueous CuSO4. Failing B solution is alkaline solution of sodium potassium tartrate, that is the salt of tartaric acid. Okay, so in copper sulfate, what is there? Cu2 plus is there. So it will be converted into Cu. Actually, it is Cu2O. This is the reddish brown product. Reddish brown product. That is Cu2O means what? 2x minus 2 equal to 0. Oxygen minus 2. So x is equal to, you see, plus 1 will come. That is cuprous oxide. So this cuprous oxide will form reddish brown precipitate, and this is the test for aldehyde. Once again, it is a very mild oxidizing agent. It will not be able to oxidize this aldehyde, so ketone into carboxylic acid. So this sorry, one more here. When you wait for just 2 minutes, this is because this is a very, out of what all we studied today, more than that, this is very important. And this is actually called as another one test only, iodoform. This is for ketone, iodoform test. Okay, because this iodoform you will get a yellow color. Yellow coloration will be formed, so easy to identify. That is why otherwise it can be bromoform and not. Here, note down these few points only for terminal ketones. So it is not possible for other ketones. So note down this point, terminal ketone. Sir, what is terminal ketone? Terminal ketone is after the ketone group, nothing should be there, or at least minimum one CH3 should be there. Here carbon can go. But this is called terminal ketone, COCH3. And again, you see that because this will be helpful for distinguishing ketone versus ketone. Suppose this is what is this? This is 2 ketone. This is pentane, pentane 3-1. And what about this one? This is also pentanone only, but pentane 2-1. They are asking distinguish between these two. The important question is that one aldehyde, one ketone distinguish is asked when you have Welling solution test, Torrance reagent test. 2 aldehyde also you have a test. I will tell you that that will come in that. Some more the properties are there. Complete. Anyway, the next class I will teach you about that. Okay, and on the next reaction I am teaching now, that will be 2 aldehyde difference. Okay, but a 2 ketones difference. 2 ketone means, see that one is pentane 2-1, pentane 3-1. What is the difference? See that this is a terminal ketone. This is terminal ketone will answer for iodoform test. And this is not terminal ketone. See, this is C. It is also called terminal ketone, or you can call it as a methyl ketone. Terminal ketone will be attached with methyl group. So write down this iodoform test will be answered only by terminal ketone or methyl ketone. The next one is this question I did not cover in alcohol chapter purposely because after studying this only will be able to see that then this test will be that I come to the end of this session. If I forget also remember that. So you told you have to say something about ethanol. Okay, so remember that. Right. Now that write down that ketone, that is methyl ketone or terminal ketone. Okay, C double bond O CH3. Here, when it is treated with NaOI, okay, sodium hydroxide plus I2 also. Sometimes they may give NaOH plus I2. That time you remember this one. This is sodium. HOI means that perchloric acid. You have studied P block element. Perchloric acid HClO3O4 and chloric acid HClO3 and HClO2 is what? What is HClO2? Tell me. Perchloric acid, chloric acid, chlorous acid. No, chlorous acid. Is it chloric acid? Chloric. This is perchloric, this is chlorus, and this is HClO is hypochlorous. Okay, now hypoiodous is what? HIO. It actually will be HOI. This is the way. Now this instead of this, what is there? This is H plus O minus that acid. Na is the sodium hypo. So write down sodium hypoiodide. Sodium hypoiodide. Di chlorus. OUS means ITE. Iodide. Sodium hypoiodide. Sodium hypoiodide. It is an oxidizing agent. Okay, it is an oxidizing. It is a mild oxidizing agent. Mild oxidizing agent. It will carry out the oxidation process also. But here, what happened? This will take this. This will take this. This here. This O and O here O. Then A, the carboxylic acid salt will come. So this I will be reacting here. How many moles will be concerned? The 3 moles. So CHI3. This is the product. Iodoform. Okay, it's yellow color means easy to identify. Observation is very good. So this will be given. So write down this reaction. And again, one more point you take that without affecting double bond. Point I think is a very big structure they have given. One is what is happening. The terminal methyl group, that methyl will be taken out. Okay. And oxidizing agent, that is why that ketone become carboxylic. See, what is this? What is this? What is this? R. Is a 2, I take this R. COONA. So ketone becomes sodium carboxylate, carboxylic acid salt. That means ketone becoming acid means what? It is oxidation. But this oxidation possible only for, it is capable of doing only for that terminal ketone, not possible for other ketone. That is why it is a special reagent. One is oxidation, and then the iodoform is formed, and another one is only the terminal ketone will be oxidized, not other ketone. Right. Now question is, I told I am coming to this ethanol. Distinguish between, one question you write down. Distinguish between, I thought of covering during CH3, CH2, OH, CH3, CH2, CH2, OH. Now tell me, any idea, any guess? See that, this is the iodoform test, okay, sodium hypoiodide, oxidizing agent. What will happen? CH3, CHO. Okay. And here what will happen? CH3, CH2, CHO. So I am writing the full form, expanded form CH3, C double bond OH. Here CH3, CH2, C double bond OH. Now see, this is ethyl group with ketone, but here it is methyl group with ketone. This is methyl ketone category. Okay, so again one more mole of here, another 3 moles of NaOI will be converting into CH3 into CHI3. Write down this. Because if you are breaking your head also, already you will not get the answer. This is primary alcohol. This is also primary alcohol. I have already given you some methods. Lucas test. Okay, Lucas test, one turbidity will appear. Tertiary immediately, secondary little slowly, primary not forming at room temperature, only by heating it will form. That by but that is for primary, secondary, tertiary. But here both alcohols I have given is primary alcohol. So how will you distinguish between? That is why it's so special thing. So remember that this ethanol only it is applicable for ethanol. Propanol and all not applicable. Methanol also will not. The formaldehyde means that you will not get any ethyl ketone. So only ethanol, write down, ethanol has ability to become methyl ketone when it is oxidized. So here NaOI is oxidizing agent. So first step is it will oxidize. Second step is being a terminal ketone, it will convert them into oxidize them into iodoform. So it will answer for iodoform test. Okay, so iodoform test distinguish between terminal ketone and other ketones. Then another one is ethanol primary alcohol with other primary alcohols. The second one. Third one is without affecting double bond, it is an oxidizing agent. Rare. Without affecting double bond oxidizing agent. So remember these points. Write down. The next reaction you heading you just write down. It is a name reaction, Cannizzaro reaction, aldol condensation, but the book they have given the heading alpha hydrogen, but it is due to alpha hydrogen. But no alpha hydrogen also no problem. It will react. So we are going to study. This is again a very important reaction. Even with the mechanism we have to study. So I think next time we will go for lunch and next class we will see. Okay, evening I thought of taking some classes, but since I have scheduled class for 10th standard, not be able to take. So we'll meet some other day. Okay. So you are free after 6 o'clock or after 4 o'clock? After what time you are free? All of you, full strength. How many attending not a matter, but you tell me not from school side, no engagement. After which time? Monday, Tuesday, Wednesday, Thursday. Okay, only one more class here, we'll finish off so that we can go for revision. Revision is only more important. Variety of individual questions we have to discuss. Okay, tell me, one of you tell me.